Hey students, hope you all will good and you all revising our concepts. And now we will discuss about some important concepts in alkaline earth metals. Just a few minutes we will complete this and we will enter into hydrogen and its compounds. Last and final chapter in our first PUC. Okay, so first if you see calcium hydroxide, what we called, I told you, slaked lime. And aqueous calcium hydroxide means calcium hydroxide in water we call as lime water. Calcium hydroxide suspension means without water, concentrated, this calcium hydroxide is called milk of lime. And calcium hydroxide we use as a building material, as a mortar. As of it's a 1 part of calcium hydroxide and 3 parts of sand and water. So this is very important, and this we also call lime mortar, actually lime mortar. So 1 part of calcium hydroxide, 3 parts of sand and water. Okay, so that is actually mortar, means what we used in a building material like that. And calcium hydroxide main properties, it's a best used as a mortar, and calcium hydroxide used to prepare a bleaching powder. What is a bleaching powder? Calcium OCl whole twice. Okay, calcium oxychloride we can call CaOCl whole twice. This actually we can write like this also, Ca plus 2 and OCl minus OCl minus. So this whole OCl minus OCl have minus 1 charge. This OCl has minus 1, this OCl has minus 1. So you can say OCl whole twice minus 2, calcium plus 2, oxygen minus 2, your chlorine is positive. The reason you know that, because oxygen is more electronegative like that. So this is the bleaching powder. The calcium hydroxide when react with the chlorine, you are getting bleaching powder. This is bleaching powder. Bleaching powder, CaOCl whole twice, and along with that calcium chloride and water will form. So this is a continuation here, water molecule. And next, calcium hydroxide will react with the CO2, calcium carbonate, CaCO3, everybody knows. Okay, calcium hydroxide with CO2 and water, then calcium bicarbonate. This is what? Calcium bicarbonate, and this is what? Calcium carbonate. Calcium carbonate, you know that we use for paintings and all, and this calcium carbonate we use for medical purpose also. Okay, in a dental we will have this calcium carbonate. Okay, and calcium bicarbonate like that. Next, calcium sulfate, CaSO4. Calcium carbonate when react with sulfuric acid is very simple. This calcium on plus 2 and sulfate minus 2. Then you will get calcium sulfate, CaSO4. Okay, very simple things, and we have to remember these formulas. That's why I written before only, to avoid time wasting actually. Next, if you see gypsum, CaSO4.2H2, that is called gypsum. What is that? CaSO4.2H2 means we can call it like that. Dihydrated. Di means how many? 2. Hydrated means what? Water molecules. So dihydrated calcium sulfate is called gypsum. Only anhydride, this is called anhydride form. Anhydrous form. Hydrated gypsum. Anhydrous, anhydride we call name. What is that called? Anhydride. They'll ask you which of the following indicates anhydride, what is the formula of gypsum, and like that they can ask questions. And one more, they can ask plaster of Paris. Plaster of Paris, CaSO4.half-H2O, that is called plaster of Paris. Gypsum actually 2 forms. One is orthorhombic and monoclinic. Monoclinic form is more stable. So gypsum, CaSO4.2H2O. I repeat, gypsum, how to remember? Dihydrated calcium sulfate. And what is the plaster of Paris? I written. Plaster of Paris, it is hemi or semi-hydrated. Semi means half. Half means what? Kazrare. So half H2O. Semi-hydrated plaster of Paris, you can write. What is this? Semi-hydrated or hemi-hydrated, you can call it. Hemi, H-E-M-I. Hemi-hydrated calcium sulfate is called plaster of Paris. Plaster of Paris, one more way you can represent, that is 2CaSO4 dot H2O. Very simple. Just multiply with 2. Certainly you will get this one or not. Correct? So CaSO4 2 moles and H2O like this. 2CaSO4 dot H2O. That is called plaster of Paris. Okay. So plaster of Paris and all this where we use gypsum, this all we use for bandages and all. See if any bone broken, hand or leg, anything broken, they will give some kind of tight cement we call. Okay, by using that plaster of Paris and all. Okay, so they will completely what we called use some white color paste here. Okay, so it make it more stiff and so that inside bone can attach. I think so. I'm not doctor, so but still you know everyone. Okay, I think everyone knows about that clearly. So next, the most important thing is setting of plaster of Paris. Setting means very simple, hard, making more harder. So than plaster of Paris, gypsum is more hard. So plaster of Paris can convert into gypsum. So how, I will tell you. So first we call setting processes. Step 1. What process it is called? Setting process. Step 1 is called setting. Calcium sulfate half H2O. This is what plaster of Paris. When you are heating with water slowly. Okay, just warm item. Calcium sulfate 2H2O will get. So this is called actually orthorhombic. Okay, which is called gypsum actually. The formed gypsum, step 2, making more harder. That is hardening state we call. Hardening state. Very simple. That gypsum we convert into monoclinic. Monoclinic form of this gypsum is called albester. Remember that one. What is the name? Albester. CaSO4 dot 2H2O. Sir, CaSO4 dot 2H2O is gypsum. CaSO4 dot 2H2O is albester you written. Then we will confuse you, sir, because having same formula. Same formula. There are allotropy forms like that. We know, no? Like that. So having a different structure and same formula actually. So CaSO4.2H2O is gypsum and orthorhombic, that is. Orthorhombic form of CaSO4.2H2O is called gypsum. Monoclinic form of CaSO4.2H2O is called albister. This is most important thing. So this is about what calcium hydroxide, few things about what they use as a mortar. Calcium hydroxide, how to use bleaching powder. So calcium hydroxide react with the chlorine gives bleaching powder formula, and their chlorine oxidation states. So why I written understood? They'll ask you chlorine oxidation state. Chlorine is +1, oxygen -2, because you can write OCl minus. So oxygen however -2, because oxygen is more electronegative. Chlorine oxidation state, if they ask, X plus of -2. -2 is the oxygen oxidation state. The whole OCl has a charge -1, so equal to -1, then X equal to +1. That means chlorine oxidation state, you are getting +1 there. Understood, sir? So this is the most important thing. Please write it down, all those things, and have a screenshot. And how to set a plaster of Paris. First, making more harder actually. Setting of plaster of Paris means. So step 1 is a setting process. Step 2 is hardening stage. In first step, this plaster of Paris converted to gypsum orthorhombic form. That orthorhombic form is converting to more harder, okay, into monoclinic form. Okay, so this is about what we call calcium hydroxide and even calcium carbonate. How to get, I told you, okay, and from calcium carbonate, how to get calcium sulfate, I said. Calcium sulfate, different forms, I said. Okay, so and one more important thing. Calcium compound, one more we have as a building material we use, know the sir, cement we called. Okay, what is cement? What are the components present in cement? We have to see actually. So first, what is cement? It's a building material. Everybody knows cement and all this gypsum and all. Okay, so in cement, what we have actually? Okay. First we have calcium oxide, silicon dioxide, Al2O3 and MgO and Mr. Fe2O3. Okay, calcium oxide and silicon dioxide, Al2O3, MgO and Mr. Fe2O3 and SO3 also you are having. So these are actually small quantities. We can call it as traces. 1 to 2% only. This also 1 to 2% only. Okay, so this is the MgO is 2 to 3% and Al2O3 is 5 to 10% in cement actually. Okay, if you want to prepare cement in industry, you have to take these compositions of all these substances. Like calcium oxide, how much you have is a 50 to 60% actually, and silicon dioxide is 20 to 25%. So components they will ask and percentages also they will ask in exam. That's why cement, what are the components? Okay, in cement manufacturing, what are the components we use? Means we can say all these: calcium oxide, silicon dioxide, Al2O3, alumina, silicon dioxide, sand, silica, otherwise sand, alumina, MgO, magnesium oxide, Fe2O3, sulfur trioxide. These are the components used, and these are the compositions. Okay, composition of calcium oxide is how much, silicon dioxide how much, Al2O3 how much, MgO how much, Fe2O3 how much, SO3 how much. Like this we will take. Understood, sir? So please have a look and write on this also. So now this chapter completed. So biological importance of calcium is there, magnesium is there. Just please go through our material or else NCERT textbook so that you can easily understand. Now just have a look about all the given concepts in alkali metals and alkaline earth metals. From S block you will get one question. Our next chapter, hydrogen and its compounds. In hydrogen and its compounds you have mainly two concepts. One is hardness of water. What is that? Hardness of water, and hydrogen peroxide mainly. Okay, of course deuterium oxide is their heavy water. So mainly three concepts. Okay, so I need just one class or two classes for that. Very simple. So we can easily understand all those actually. So you have to write this also, please. Now we have to discuss about hydrogen and its compounds. Okay, so I will complete this in just two classes, 2 or 3 classes, that's it. Sir, even if we have 2 classes in our schedule also, no problem. I will do one video extra and you can listen anytime, not a problem. But clarity is important and learning every point is very important, so that from S block one question, from hydrogen compounds one question you can have easily. Okay, from periodic table, chemical bonding, almost 3 questions. 3 plus 2, 5 questions already over. Correct or not? So in P block we will have 7 questions. Whole P block at one place we will learn, but mostly that P block we will have offline easily. So that 7 questions, every line to line we will understand. So 7 questions you can answer very clearly. Just believe me, because I will give you some tricks also to remember all the things what we have in P block. So don't worry about that. So in that way, almost 10 to 12 questions we can easily answer. Okay, sir. Now come to this hydrogen and its compounds. So about hydrogen we have to know first. So hydrogen means everybody knows it is a diatomic gas, H2. So hydrogen is a diatomic gas actually. Correct? Who is diatomic gas? Hydrogen is a diatomic gas. Everybody knows this. Correct, sir? So hydrogen have what properties? Hydrogen have similar properties. Similar properties with alkali metals with 1A group and halogens. And what's a halogens? So H2 have similar properties with 1A group and halogens. That's why you remembered or not, hydrogen placed along with alkali metals, but hydrogen is just a starting element. That's why we kept along with the alkali metals. And one more thing, why hydrogen is present along with the alkali metals means, in modern periodic table if you see, we will consider electronic configurations. Outermost electronic configurations, if you consider, hydrogen 1s1, lithium 2s1, sodium 3s1, like that you have. So that's why hydrogen placed along with the alkali metals in a same group actually, but hydrogen we never consider as alkali metal. Remember this one, hydrogen is a diatomic gas. So hydrogen have similar properties with 1A group and halogens, I said. So what are the similar properties? Let's see. So H2 similar properties. H2 similar properties with what? With 1A group. What is 1A group? Alkali metals. As I said, having same electronic configuration. Same electronic configuration. Second one is can lose one electron so that exhibit or can exhibit +1 oxidation state. Same electronic configuration, but what configuration? Outermost configuration or valency shell configuration. Okay, same electronic configuration, and H2 can lose one electron, so exhibit +1 oxidation state. Who will exhibit +1 oxidation state? The hydrogen exhibit +1. Of course, alkali metals exhibit +1, and like that can be a reducing agent, and it is reducing agent. Like alkali metals are reducing agents. I told you, even order of reducing ability. Lithium is the most or strongest reducing agent, I told you. So can act as, otherwise you can write what is this? Shit. Can act as reducing agent actually. These are the similar properties of hydrogen with 1A group element. But actually hydrogen H2 have similar properties. H2 have similar properties with halogens actually. With halogens. With what's the halogens? So what is that? Hydrogen is a diatomic gas. Like halogens are diatomic. So diatomic gas, like halogens, H2. Correct or not? Like what? Like halogens. Halogens are F2, Cl2, Br2, I2, like that. Correct? So hydrogen exhibit +1, I said. Hydrogen also exhibit -1. Hydrogen also exhibit -1. So hydrogen exhibit +1, you said. That's what I said. Hydrogen when exhibit +1 with non-metals. Hydrogen when exhibit -1 with metals. Like many times I told you here, like examples, HCl, H plus Cl minus. But here you have a sodium hydride, like that if you see Na plus and H minus. There hydrogen has a minus oxidation state, negative oxidation state actually. Correct or not? And third one, high ionization potential. Like halogens, hydrogen have high ionization potential. And having single bond, like halogens, like F single bond F and H single bond H, like this. That means accepting tendency. Hydrogen can accept one electron, so that exhibit -1. Halogen can exhibit -1. like that. If suppose hydrogen accepting one electron, it becomes H minus. H minus means what configuration? 1s2, noble gas configuration. Like fluorine will take one electron and convert it to F minus. It's noble gas configuration. 1s2, 2s2, 2p6. 2s2, 2p6 means noble gas configuration. So this is very important. So these are similarities actually. So similarities of hydrogen with 1 group elements are what we have here. Similarities of hydrogen with halogens, what I was given here. So hydrogen actually you can place along with halogens, or else hydrogen you can place along with alkali metals. But why hydrogen kept along with alkali metals? It's a starting element, and one more important thing, electronic configuration. That's it. So hydrogen have three what we call isotopes. Everybody knows, correct? So this is a very important right now. So next we have those isotopes, and after isotopes we have few more, like how to prepare hydrogen and all we will have. Okay, see, if you see hydrogen and a 1H1 and a 1H2, I will write here 1H1, 1H2 and 1H3. This is called protium or else hydrogen simply, which has proton 1, electron 1, no neutron. Neutron is 0. Okay, 1 is the atomic number, it is mass number, everybody knows. Okay, 1. So isotopes, these all three, everybody knows. Isotopes, it's a radioactive, it's a tritium we call tritium. Okay, next this is called heavy hydrogen we call, or else deuterium, and we call heavy hydrogen. Okay, or you can call it as like tritium. Okay, T3 like that. Okay, tritium, deuterium, D. 1H2 we can represent D. This 1H3 you can represent T. Okay, so deuterium has how many protons? Protons are, electron is 1. Okay, protons, how many? Protons always, sorry, electrons 1 and proton 1. But neutrons is 1, because 2 minus 1, Z minus atomic number, yes. So number of neutrons 1. So here tritium, if you see, proton 1 and electron 1 and neutrons are 2 actually. So who is more heavy among this? Tritium. Most abundant is hydrogen. You know, in universe 70% you have hydrogen only as a water and all remaining. Okay, so it's most important, and among these three, what we call isotopes, this is more abundant, this is very less, 0.15 something, it's in traces, tritium. So very less abundant all these three. Next, if you see some preparations of hydrogen you can prepare in many ways. So let's see one by one. Okay, we will have, so that we will enter into deuterium, heavy water, deuterium oxide, and heavy, what is hardness of water, and hydrogen peroxide later on. So next is preparation of H2. You can have by electrolysis of Mr. Water. Electrolysis of what? Water. So water on electrolysis by using platinum electrolysis in presence of platinum electrode, because hydrogen cannot act as electrode, no, it's a non-metal. So if you see 1 mole you can take, or 2 moles, then you will get H2 plus 2 moles H2 gas and O2 gas you will have. This is one process. And the second one is electrolysis. This you know actually. Electrolysis of brine solution. What is brine solution? Mr. Aqueous NaCl, brine solution. So this everybody knows. First, actually at anode what happened, cathode what happened, everybody knows this. On electrolysis you will get 2Na plus 2Cl minus. So at anode what reaction takes place, you know? At anode 2Cl minus and converted to Cl2 plus 2 electrons, like this, correct? And at cathode what happened, you know this water actually there, NaCl aqueous, water will undergo reduction, H2O will take 2 electrons and convert it to H2 plus 2OH minus, like this, correct? And you can have in a one more way from hydrocarbons actually. Hydrocarbons, when you are heating hydrocarbons, CN H2n plus 2, when react with water, then you will get what you know, moles of CO and 2n plus 1 H2 you will have. This is general hydrocarbon. Suppose let's see CH4 when react with H2O, then you will get CO, okay, n number of carbons. So CO plus 2n plus 1, as I said, 3, 4 and 2, so 3. Okay, so here what you have, like the CH4 when react with H2O at around heating 1000 degrees Celsius you will get. Okay, so what is N here? 1. Understanding? N is 1, Cn. Okay, so you can have 2n plus 1. So N is 1, 2 into 1 plus 1, 2 plus 1, 3H2, like this you can. Generally, this is the general hydrocarbon hydrolysis at 1000 degrees Celsius. In this way, you can have H2. Next, one more important thing is salts or metals when react with acids, then you will get H2, because metals replace hydrogens, right? Suppose calcium when react with H2SO4, then you will get calcium sulfate plus H2. So this is also many like Na. So Na, 2 moles of Na when react with H2SO4, then you will get Na2SO4 plus H2. Copper when react with. Actually these are explosive, sodium and all like this. But instead of that, better to take some less reactive metals like copper when react with H2SO4. Then you will get copper sulfate, CuSO4 plus H2. Like this you have preparations. And one more preparation is there, Bosch process, and preparation of water gas like that. Water gas means what? CO plus H2. Okay, so those all we can have later, and heavy water and hardness of water in our next class, and hydrogen peroxide one class. Clearly we will learn, because either hardness of water or from that hydrogen peroxide you will have a pakka question. So you have to understand those two. Thank you.